All right, guys, I know you're ready for this. Whether you believe me or not, you are ready for this problem right here. So we have letters, we have numbers, we have letters out of the house, numbers into the house, numbers outside the house. So let's conquer this. So the 3 is already outside getting fresh air. We are gonna just keep it outside. Now let's divide it up each like its own kind. So the numbers and each letter in its own house. We're going to simplify each letter by itself, so this helps us to see it better. All right. Now, again, the 3 gets ignored. Nothing against the 3, but the 3 gets ignored. 84 is 84 a perfect square? Well, if I'm looking at my perfect square chart, I can see that I'm not there. Okay, I can see that 81 is a perfect square, but 84 is not. So I'm going to go ahead and I'm going to keep dividing all the way until I find the perfect square that divides into it. And hopefully you went all the way to 4. So 3 times 3 times the square root of 4 times the square root of 21. A is not a perfect square because it does not have an even exponent. So it is just going to stay by itself. B to the 4th is a perfect square. It's an even exponent. So we're going to keep it like that and we'll simplify it in a second. C to the 7th is not a perfect square because it is not an even exponent. So we're going to rewrite it C to the 6th times C. C to the 6th is a perfect square, and we'll take its square root in just a second. D to the 5th is also an odd exponent, so it's not a perfect square. So we're going to rewrite it D to the 4th, an even exponent, times D. Now let's go back and take out our perfect squares. 3 is going to have some more company outside in just a second. The square root of 4 is 2, so it goes out of the house. I'm going to put a box around this to remember that it stays in the house. A stays in the house. The square root of b to the 4th is b to the 2nd, because remember, with letters, we add the exponents. So that guy is out, as is 4. C to the 6th is c to the 3rd. C to the 3rd times c to the 3rd. If we add the exponents, we get c to the 6th. However, c is left inside. D to the 4th, when I bring it out, is d squared. D is not a perfect square and must stay in. So I have all these perfect squares getting fresh air, and I'm left with 21 times A times C times D. Now we have to clean it up, remembering that if a letter has an odd exponent, as it's been taken out of the radical, it needs absolute value. So I can multiply my numbers times my numbers. 3 times 2 is 6. B to the 2nd is an even exponent, so that doesn't need absolute value. C to the 3rd does. D to the 2nd does not, and everything inside stays the same. I guess we should check one last time. Whatever's in the radical, 21, is not a perfect square. 16 does not divide into it evenly. 9 does not divide into it evenly, nor does 4. So this whole expression is a simplified version of what we started with.